Look at Mercury through a telescope, and you see a quiet, heavily cratered rock. It has no atmosphere, no liquid water, and an entirely frozen crust. Visually, you could swap it with our moon and hardly notice the difference. But when robotic spacecraft flew past this sun-baked world, they detected a massive, invisible energy field. Mercury projects a global, pulsing magnetic force field into space. According to the strict laws of planetary formation and thermodynamics, this is a scientific impossibility. A planet this small should be completely frozen and geologically silent. Think of a small cupcake baking next to a massive wedding cake. When you pull them out of the oven, the tiny cupcake loses its heat to the cold air and freezes incredibly fast. Planets follow that exact same rule of thermodynamics. To generate a magnetic force field, a planet needs a working dynamo. That requires three things: a pool of liquid metal, intense internal heat, and a spinning planet. These elements work together to organize the churning fluid into massive electrical currents. Earth's core takes up half its radius, but Mercury is an anomaly, a giant iron marble wrapped in a thin crust, taking up an astonishing 85% of the planet. Despite this massive heart, its magnetic field is incredibly weak, barely 1.1% of Earth's. So we are left with a direct contradiction. Because Mercury is so incredibly small, it should have lost all of its internal heat billions of years ago. Without that heat, its massive iron core shouldn't be churning, and its dynamo engine should be permanently dead. During its violent formation close to the Sun, Mercury swept up a surprising amount of volatile elements, trapping an estimated 3 to 5% sulfur inside its dense core. If you mix salt into a glass of water, the freezing temperature drops. Sulfur does the exact same thing to liquid iron. It acts as a powerful cosmic antifreeze, keeping the iron in a sloshy liquid state at temperatures much lower than pure iron could endure. This sulfur mixture explains how the planet avoided freezing completely solid over the last 4 billion years. But liquid metal sitting perfectly still doesn't generate electricity. The planet still needs a way to churn that liquid without the intense heat normally required to boil a core. Earth's core freezes from the center outward. Mercury does the exact opposite. Because it is rapidly losing heat to space, the very outer edge of its core, where the liquid metal touches the cooler rocky mantle, drops below the freezing point first. As the outer layer cools, pure iron crystallizes. Because solid iron is heavier, these crystals steadily sink towards the center in a dense metallic snowstorm. Sinking flakes drag fluid down, leaving a lighter, sulfur-rich liquid that bubbles back towards the top. This creates a continuous, gravity-driven cycle. Mercury doesn't need to be blisteringly hot to boil its core. It uses the physical weight of billions of falling metallic snowflakes to constantly stir the liquid, generating electrical currents that keep its dynamo alive. In 2011, NASA's Messenger spacecraft mapped this resulting magnetic field and found a severe geometric error. The magnetic dipole, the imaginary bar magnet inside the planet, is broken. It sits roughly 500 kilometers north of the equator. Physicists determined this strange offset is maintained by a self-regulating feedback loop. The northern shifted magnetic field physically pushes back against the liquid metal inside the core. It suppresses the churning fluid currents in the southern hemisphere while actively boosting them in the north. This internal machine effectively engineers its own lopsidedness. The core uses its own generated magnetic force to maintain a permanently unbalanced storm, keeping the northern half of the dynamo churning while the south remains sluggish. But this bizarre engine is trapped. Right at the top of Mercury's core sits a thick layer of unmoving liquid metal. Because heat transfers differently through this specific chemical mix, this top layer doesn't churn at all. It is stably stratified. This dead zone acts as a dense electromagnetic muffler. Any magnetic waves generated by the deep metallic snowstorms have to pass through this thick, stagnant blanket, which absorbs and heavily degrades their signal before they can reach the surface. Outside the planet, things get worse. The intense solar wind blasting off the sun constantly compresses Mercury's weak shield. This intense pressure induces powerful electrical currents in the planet's rocky crust, generating a separate magnetic force that runs in the exact opposite direction, actively fighting the internal engine. Mercury possesses a massive, active iron heart, but its magnetic field is effectively choked to barely 1.1% of Earth's strength. It is caught between a stagnant internal dead zone and the constant crushing pressure of the sun. Humanity is currently en route to study this precise impossibility. The joint Bepi-Colombo mission is heading toward the inner solar system right now. When it arrives in orbit, it will deploy dual spacecraft to map this lopsided field in full 3 dimensions, using advanced magnetometers to listen for the deep acoustic signatures of the falling iron snow. Mercury is a planetary survivor that bends the strict rules of thermodynamics to stay active. It forces us to look at the churning iron core deep beneath our own feet and wonder if, billions of years from now, Earth's stable magnetic shield could eventually degrade into a lopsided, self-regulating snowstorm.